Climate change is already causing disruption to our environment and communities, which is expected to worsen in the coming years. An increase in the frequency and severity of storms will affect flooding and erosion in river catchments. There have been major advances in understanding the future impact of storms on flooding and in assessing the resilience of critical infrastructure to flooding. But little has been done to predict erosion hazards in river catchments. Erosion has major impacts on infrastructure. Erosion on riverbeds causes bridges to collapse. Erosion on riverbanks and hill slopes causes costly damage to roads, buildings, flood defences and dams, and can cause electricity towers to collapse on floodplains. While erosion of farmland damages or destroys crops and degrades river water quality. Erosion presents major threats to human life, infrastructure, the economy and food security. Without predictions of future impacts of erosion hazards, those responsible for protecting critical infrastructure face questions that are very difficult to answer, such as where to act to make infrastructure more climate resilient? When is action needed to mitigate erosion impacts? Should action be taken now, or can investment be postponed? The University of Liverpool have sought to answer these key questions through the development of a computer model. The model simulates storm events of differing duration and intensity, both for current climatic conditions and for those predicted to occur in the future. These models are used to generate erosion maps, which identify infrastructure presently at risk and show how erosion risk changes with climate. Economic damage maps show where and when protection is required. The information in these map models allows stakeholders to assess how to respond to erosion hazards and how to reduce hazard costs while improving the resilience of critical infrastructure to climate change.